Today we are moving on to 9-6 and we are identifying symmetry. We're doing symmetry. So a couple of things with symmetry. One is reflectional symmetry. It's the same thing as line symmetry. And it's the figure can be mapped onto itself. So the main idea is this. When you were little kids and you were in preschool, do you remember when they painted your hand with paint? And they had you put it on a piece of paper and then you folded the paper in half and you smushed it and then you opened it up and you had your own unique butterfly. They were teaching you symmetry. That's really what they were doing. It was a very basic symmetry, but that's what they were teaching you. And so you're going to notice in this first picture, the line of symmetry is the body of the butterfly, okay? And we'll be watching a video a little bit later that is attached to this. And it talks about line symmetry and rotational symmetry and what that looks like. There's a lot of symmetry in nature, just automatic. So it's kind of fun to watch. Here's a shape. Notice that there's one line of symmetry here. What that means is I can cut it in half and the one side matches the other half. You could put a line here, but does the top match the bottom? It does not. So that is not a line of symmetry there. There's only one on this shape. Let's keep going, and let's look at lines of symmetry on different shapes, and we're going to draw them in. So let's take a look at the star. I'm going to give you a minute to draw in the lines of symmetry, and then I want to find out how many you think are in that figure. Okay? How many lines are there? More than 3.
4.
Let me give you a hint.
5.
There are 5. Yeah, there's one that goes like this. There's 1. There's 2. There's 3. There's 4. And there's 5. Okay, so there's 5 lines of symmetry. Now, when you do this on your exam, I can give you a straight edge if you want me to. You don't have to be like it has to be exactly straight, okay? You can see one of mine was a little swervy, but you can tell that I know what the line of symmetry is based on it, okay? All right, let's go on to this one. Here's a capitalized I. How many lines of symmetry do you think is on this shape?
2.
There are 2, that's correct. Where's one of them?
Cut it in half.
Cut it in half how?
This way.
Okay, like a horizontal line. Very good. So there's one that way, and there's one that's vertical. Yep. So there are 2 lines of symmetry on this shape. All right, let's take a look at this shape. Now, some students would be like, what is this? Is this a square? Is this a rectangle? Like, what is it? When in doubt, ask me. I'm going to tell you that this is a square. And it does make a difference, okay? So if I take a look at a square, here's an example of a square. How many lines of symmetry would this square have? There are 4, okay? There's the obvious ones that are, horizontal and vertical. But the other ones are diagonal. So if you took an actual piece of paper and you folded it, you can see how the one maps directly on the other. Okay? So there is one that goes this way, and there's another one that goes this way, and there are 4. Questions so far? Okay, let's move on. This is a parallelogram, so it looks kind of like there on the picture. I'm going to tell you it is not a rhombus. It's just a parallelogram, okay? So how many lines of symmetry would this shape have?
2.
Okay, you say 2. How? Okay, so diagonal, right? If I actually take one and I fold it, do you see how the diagonals don't match up? They look like they do, but they don't. Okay, same if I took it the other way and I folded it. Do you see how they don't match up? So there are no lines of symmetry on a parallel on this particular parallelogram that I have based on the shape. If it was a rhombus, yes, but if it was stretched out more, no. Could I go horizontal?
No, ma'am.
No. Can I go vertical?
No.
No, can't go that way either, okay? So there are 0 lines of symmetry on this. And again, it depends on the parallelogram, okay? All right, let's keep going.
0.
Here is a guitar. How many lines of symmetry?
1.
There is 1. Where is it?
Fold it like a hamburger. I mean, a hot dog.
Hold it like a hot dog, not like a hamburger, right? Very good. So there's 1 line of symmetry there. Not all guitars are symmetric like that, right? Because sometimes they have that piece that's cut out of it. So, all right, how about this word?
1.
1, where is it?
Fold it like a hamburger.
Like a hamburger, right? Yeah. Or if it's the word wow, right? And some words are like that. There's special types of words where we can fold them in half. What do they call it? Like a palindrome?
Don't even know what that is.
I can't remember if it's a palindrome or it's, but there is a word for it where I actually have a word and I can cut it in half and the one side matches the other. I think it's a palindrome. Yep. All right. Yes.
20.
20. Let's see if he's right. Okay. There's 1, 2, 3, 4. Whoops. 4, 5. And then we'll go. Whoa, I gotta look.
Whoa.
It's hard for an old lady. 6,
You're not old.
7, 8, 9. I got 10. Where'd you get the 20?
I just counted the pedals. I didn't think. Yeah.
Okay.
See, I told you 10.
So it can be kind of deceiving, can it? We okay?
Yes.
Yeah. So 10.
What is this?
Or could this happen? Let's look at this a little bit closer. That's a good question. Could I go from here to there? Would that work? No, it doesn't. Do you see why?
Yeah, it doesn't.
Do you see how this one comes out and this one here? Do you see how that's tucked under? So that won't work. So there are 10. But that's good to have that question. All right. So those are lines of symmetry. And you will have that on your test. You will have different shapes, and I'm going to ask you for how many lines of symmetry. Okay? All right, let's move on. Rotational symmetry. Rotational symmetry is I can have a shape, and I can take like a pencil and put it through it, or like an umbrella, you know, the spout that goes through it. And I can take this thing and I can rotate it, and it maps directly on itself. Like I have light that shines up from underneath it, and when I rotate it, I don't see any light that goes through it. It like covers the whole, okay? So rotational symmetry happens when that rotation can be mapped onto itself 180 degrees or less. This is what's key, is right here. It's 180 degrees or less. So this is how we do it. First of all, this is a regular triangle. Would it have rotational symmetry? Yes, it would. And the reason why it would is I can put something in the middle of this, and I can match this corner up onto this corner if I rotate it, and it would match. Okay. How many lines of symmetry? Let's go ahead and draw it. How many do you think we have here?
3.
Okay, let's see if you're right. Here's 1. Here's 2. Here's 3. Okay, so 3 lines of symmetry. Okay, now to find out how many degrees, you're going to take 360 degrees, and it's always 360, and you're going to divide it by the number of lines of symmetry. So in this figure, it's 3, so I'm going to divide it by 3, and I get 120 degrees. And then to find out how many other degrees of rotation, what you would do is any of them that repeat between 0 and 180. So for example, this is 120. If I did another 120, it would be 240. Does 240 land between 0 and 180? No. So I am done with 120 degrees. I'm done. Okay, I can't keep adding 120 degrees because I got to stop at 180. And I'll help you with this. We'll do a couple more, and by the time we get done, you'll be like, oh, this works. All right, let's take a look at the next one. Does the object have rotational symmetry? Okay, this is a square. So if I took a square, okay, and I put a pen through the middle of it, like that, okay, can I rotate it so that it maps on itself? So if I take this and I rotate it like that, and then like that, and then like that, does it have rotational symmetry? It does, okay, so it'd be yes. Okay, now I got to figure out how many lines of symmetry. How many on the square? 4. We talked about that before. So here's 1, 2, 3, 4. So 4 lines of symmetry. Okay, now I got to look at rotational symmetry. So I'm going to take 360 degrees. I'm going to divide it by 4 because there's 4 lines of symmetry. And I end up with 90 degrees. Okay, so now I got to find out how many rotational symmetries are between 0 and 180. So the first one is 90. 90 plus 90 is 180. 180 plus 90 is 270. Is that one? No, because I have to stop at 180. So there's 2 rotational symmetries, 90 and 180. Where students struggle with this is they don't get all the lines of symmetry. That's one of them. And then another one, they don't include all the rotational symmetries. They stop at 90 and call it done. Okay, let's keep going. This is a regular octagon. It doesn't look like it, but it is. So when in doubt, ask me, and I'm more than happy to include you on that. Would a regular octagon like a stop sign have rotational symmetry? It would. Yep, it would. So how many lines of symmetry are there? How many do you think? Guess. Yeah, 4? Let's take a look. That's worth a shot, right? So one can be this way, right down the middle. One can be like this. Another one could be like this. And another one could be like this. So there's 4, right? Okay, but there's also with the diagonals. You can have more of them. So here's another one. Regular shapes tend to have a few more than an irregular shape. So this actually has 8 lines of symmetry. Okay, so I'm going to take 360, divide it by what? 8, because there's 8 lines of symmetry. What do I get? 45. Thank you. Okay, so now I have to pick up all the rotational symmetry degrees. So 1 is 45. What's the next one? 90, because 45 plus 45 is 90. What's another one? 135, because 90 plus 45 is 135. Is there another one? 180. Is there any more? No. So again, how I get these is 45 plus 45 is 90. 90 plus 45 is 135. 135 plus 45 is 180. So you just keep adding 45 onto the last one. You stop at 180 per the definition. Questions? All right, let's keep going. One of these will be on the test, just kind of heads up. Okay, does this X have rotational symmetry? Yes, it does. Okay, it does. How many lines of symmetry are there? 4. Yeah. 1, 2, 3, 4. So 4 lines of symmetry. Okay. We said I had a rotational symmetry, so what am I going to do? Very good. Yep, 360 divided by 4 because there's 4 lines of symmetry and I get 90. Okay, so now I got to find all the angles of rotation. I get 90 and 180. Any more? No, I'm done. Stop at 180. Last one, trapezoid. Does a trapezoid have rotational symmetry?
No.
It does not, because the only time for it to map onto itself is a total 360 degrees. So I can write no rotational symmetry. How many lines of symmetry, though, does it have? It does have 1. And 1 line of symmetry. Okay, here's a note. Half a turn is the rotation of 180 degrees. So if I take something and I do a full 180 degrees, that is rotational symmetry. Okay. Now, here is some symmetry in everyday life. We'll be watching it in class, but if you're taking notes, make sure that you watch this because it's really interesting to see nature itself has a lot of rotation. It has a lot of patterns that naturally occur, so it's kind of fascinating to watch.